So, good evening and welcome to the week 6 of the problem solving session for the course Earthquake Geology, a tool for seismic hazard assessment. And here I am, Anjali Dikshit. So, let's begin this session. But before delving into the terminologies that sometimes might get confusing. So, just to clear up the meaning of each and every word that we'll use frequently in this course. So, first I will discuss the basic definition, though there is a very slightest difference between all these three terms, but it's good to refresh the concept. So, first if we talk about the fracture, okay. So, we know that when rock breaks in response to the stress, so the resulting feature that we got, we called it as a fracture. Now, what's the difference between the fracture and the fault? So, whenever there is a relative movement along that fracture, we called it as a fault. Now, moving to the third category or the third terminology that we have is the joint. So, there is a confusion between the fracture and the joint, because in both these scenarios there will no relative movement between both sides of the fault or the fracture. But the distinguishing part is that along, like whenever you see any landform, you'll find fracture, only one fracture would be there, but in terms of joint there would be a lots of fractures having the same orientation. So that's the major difference between the fracture and the joint. And sometimes the same orientation joint we called as a joint set also, because there is more than one joint, so we call it as a joint set as well. And the orientation of joint could be inclined, vertical and horizontal. So always remember that apart, like unlike the fault or the fracture, which are mostly inclined or sometimes vertical as well, but joint could also be in horizontal direction. And in the subsequent slides we'll see that how joint looks like through a field image, but for now this is the difference between these three terms that we will using during this course. Now, moving to the problem that we have for this, the first problem is that now here we have one field picture, and now we want to identify whether it is a normal fault, strike fault, reverse fault or none of the above. But I think by that time we all can understand that there is a fault. It is a fault. So definitely none of the above would not be the answer, because there is a relative motion between both sides of this fault. Now the question comes, how we demarcate it, what side of this fault is a hanging wall and what side of this fault is a football. So now to understand this thing, okay. Now here we can mark, first let's mark the fault plane. So here this is the fault plane. Okay, I hope all you can locate the position of the fault plane. And along that fault plane we have a one side of block like this, that I am marking with, like, let's write it 1. And this is the other side of the fault, let's mark it with 2. Now if I'll draw a perpendicular, okay, perpendicular along this fault line, so this perpendicular would be like this, okay, and let's mark the arrow. Now whenever you see that the side of the perpendicular which is moving towards the upside, we called it as a hanging wall. So here the block 2 would act as a hanging wall, because this perpendicular is going upward in this direction. And if we go to the other direction, which is this direction, here this arrow is going towards the downward side. So we'll mark this first block as the football. So if I have to write, so this would be my hanging wall and this would be my football. Okay, I hope this thing is clear, right? Okay. Now moving forwards, let's understand this terminology or little like background of these terminologies. So these terms were mainly originated, like these are the minors terminologies that we use. So what happens, like in this first picture you can see that this minor is working along the fault, and the side which is the upside or which is along its head, you can see this thing or you can understand this thing from this cartoon diagram. So the side which is along this head, that's why this head wall name came, and the side which is the below or which is along its foot would be called as the foot wall. So this is just to give you a brief like from where this terminology came. So it came from the mining engineers perspective. So that's why they use this name hanging wall and the foot wall, which looks very logical now. But if you want to understand through the field diagram, so this is the way I find it convenient to understand. There could be another way as well to demarcate the hanging wall and the foot wall, but I think this is explainable. So if we'll try to answer this question, so would you like to answer that? What could it be, like what kind of fall it is now? Now here the hanging wall is going upward and the foot wall is going down. So what it could be? Normal fault. Think twice. So what is the definition of the normal fault? Yeah, so how it could be a normal fault, because here the hanging wall is going upward. Yeah, correct. So the answer would be the reverse fault. And can you tell me like what kind of stress condition it get formed, like the reverse faulting, whether it would be the tensional environment or it would be the compressional alignment? I think it's very much based on the logic. Just apply a logic that what will happen when we compressed it, or what will happen when there will be a tension or the extension. The movement, like why the hanging wall is moving upward direction and the foot wall is going, now we know that it's a reverse fault, that's okay, but what kind of stress condition could lead it to the reverse fault? I think in the last lecture we have understood that there are three kind of stress condition. First is the extension or the tension, second is the compression, and the third one is the translation. Okay, I think when we'll go further, then I think it would be appropriate to ask once again. Okay, so far I think marking of hanging wall and the foot wall is clear to you, right? If you have any doubt, you can ask it right away. But if you want to demarcate, then how you will be standing at, like you have to first look for the fault plane. This is the way you can mark the hanging and the foot wall. So whenever you see the fault in a field, just first identify that where this is the fault plane. Once you will identify that okay, this is the fault plane, then only you can mark it what is the hanging and the foot wall. Can you show me like any field picture that you have, like through which only I think I can answer, otherwise I am unable to visualize the condition which you are referring to. So if maybe in the next time if you have any field picture or you can find it on the Google, I think like with that we can discuss it. That discussion would be more constructive, because still seriously I am unable to understand what kind of scenario it would be. Yeah, sure. Then. Wait. Okay, I'm stop presenting. Okay, are you sure? Okay, settings. Okay, now try now. I think it will work. Okay, yeah, it is. Yeah, it is now. I have included in this presentation, so we'll come to that, then I'll discuss in detail. Okay, so I think we have understood this thing so far. Now moving forward, so there's another field photograph of the famous San Andreas fault. Now you must be knowing that there is basically two categories of the fault. First is the strike slip fault and the dip slip fault. Yeah, under dip slip we have a normal fault and the reverse fault. Okay, why we are saying that they are the dip slip kind of fault? Because there the movement is happening along the dip of the fault. Okay, so you know like what is the dip and the strike of the fault. Okay, so this San Andreas or the transverse fault are kind of strike slip fault, are the example of the strike slip fault. Now what they are asking, that like just analyzing this figure, now tell me like what you can say about it. Like there is a off stream in the offset in the stream, like one stream is here and then other stream is starting from here. So there's this kind of change in the stream path. Yeah, so what kind of fault it could be? Yeah, these are the options. But why it's a oblique slip fault? Now first tell me what is the oblique slip fault? Okay, correct. Now, so in this figure can you see that there is any dip slip movement? Like there is this one horizontal line which is a strike line. Okay. Now but there we not able to see the dip movement, or if you are talking about this kind of dip movement, then this is not a very minute one, or this is not formed due to the relative motion between these two side of block. Otherwise you could find some pattern in this side, but there is no like friction kind of pattern are present on this this side of this block that you are talking about. So definitely there is no dip movement has happened among these two. Yeah, so that's why it is not a dip movement. So only the strike movement, because in this block the stream is indirect in this at this position, and on this block the other side of the fault block is direction got shifted. And how it got shifted? So this is the question. Definitely there some movement has happened due to which there is a offset in the stream path. Blind fault. Don't throw random words. Yeah, it's definitely not a blind fault, because if it would be a blind fault, then we will not able to see it on the surface. That's the meaning of the blind fault, right? We have discussed. नहीं कहाँ, मतलब कहाँ नहीं देख पा रहे हैं? हाँ हाँ but they are sharing the same fault line. And okay, yeah, definitely there is no feature if we talk about for this particular area. So yeah, there is no feature, but the feature that we are specifically talking about is over here, because because on that basis only we can comment it, like what kind of fault is on the field observations or from the field pictures. Sorry. Okay, is it now? I think I have made a bit clumsy. Let me clear it. So I hope it's now very clear. Okay. Okay. Okay, no problem. So see, whenever you got this kind of questions where you have to comment that what kind of fault it is, so what you will do, you just identify the features on the basis of this picture only that are present. So what we can see that, so what this picture is showing, that there is an offset between in stream path, and there is a horizontal offset, there is no vertical offset is present. So this horizontal offset definitely could be led by the strike slip fault, because if there would be a, now if you say that you can see that it is in a very like little bit deeper area, so but here we are talking about in geological terms, so these much of centimeter or meter distance doesn't matter. So if we simply see on the basis of the offset in the stream, so it would be a reverse fault. No, but like if it is a strike slip fault, then there is no concept of hanging and the football, because there is no movement along the dip. There is only a horizontal movement, and for this kind of fault we talk about their dextral or the sinistral terminology we used. We don't use the hanging and the football concept over here. That concept is for the dip slip fault, which are the normal fault and the reverse fault. Okay, you are confused, no problem. So so at what point you are getting confused? Yes, right. हाँ we use the concept of, if you want me to go there, I have already incorporated that because I knew that there would be a doubt. So we call it this kind of fault as a strike slip fault because there a slip is happening along the strike, right? Strike means the horizontal line, okay, right, and dip is the inclined or the the deeper line which is going deep. So if we talk about the strike slip fault, there we don't use the hanging and the football concept. What we do use? We use the concept of whether this block is going in the right hand direction or the left hand direction, and there is a word called dextral if it is going the right hand direction, and the sinistral when it is going in the left hand direction. Now the next question comes, how we can identify. Sorry, can you repeat it again? Dip is always perpendicular to the strike. No. No. Okay, I think then we were on a very different pages. Okay, let me let me draw a simple basic diagram to explain you. How can I draw? Okay, if we have a fault plane like this, and okay, for that you have to okay, now I need your little imagination. Suppose there is a inclined line, ठीक है? How can I explain? Okay, ठीक है. Suppose there is a inclined line that we have been discussing so far. Okay, like this. So from this figure, let's understand. So now you know that this is your fault plane, correct? Okay. But this is what we are seeing right now. It's a 2D image, but in actually everything is in 3D. If we talk about the Earth, okay. So this is my fault plane. Now at this point I am at the surface, but this block will not be confined only in the 2D direction. It will extend to this direction also if I'll go like this now. So the horizontal intersection that I'll get now on the surface, that is called as a strike of the fault. So the line that I've drawn, it looks like inclined line, but it is a horizontal line that will cut along this surface that you are seeing. It's like in 2D it's hard to show you, but I hope you are getting my point, what I'm trying to say. Like if you extrapolate the fault plane, okay, and when it cut to the surface, so the intersection that you got, that would be your strike, that is on the surface, the Earth surface. And that's why no, can you repeat it again? Yes. It's clear ना? हाँ, तो जो ऊपर से वो लाइन दिखेगा, हाँ, वो तुम्हारा स्ट्राइक होगा. Okay, and that's why like if we take this figure now, so there अभी ऊपर का ही कटा हुआ दिख रहा है, so सो इट्स अ स्ट्राइक. बट अगर हम थोड़ा नीचे जाएंगे, सपोज ये थोड़ा इंक्लाइन लाइन होती, सो दैट इंक्लाइन लाइन वुड बी माई डिप. ओके, एंड द सरफेस एक्सप्रेशन कि जिस तरीके से पूरा कट कर रही होगी ऑन द सरफेस वुड बी माई strike. I hope now things are clear to you. Okay. No, that's why we are here, no? So no issues, don't think that way. But yeah, I would be happy if I'll be able to clear your doubt, and I hope I did my job. So I hope it's clear, right? If not, then yeah, you can ask. So yes, so since it's a horizontal line, so that's why we don't talk in terms of hanging and the footwall if we talk about the strike slip fault. So what we talk, whether the block is moving in the right hand direction, that is dextral, or in the left hand direction. Now how do you identify whether it's a dextral or the sinistral? So now that's the question. So it's a very easy way to identify. Suppose you are standing on this side of the block, okay, someone is standing like this, and you are just you other side of the block, जैसे छत पे खड़े होते हैं और दूसरा साइड देखते हैं दूसरे सामने नेबर को. So now that सामने वाला जो नेबर है, suppose this block, whether it is going in my left hand direction or the right hand direction. So now imagine this scenario and tell me whether you identify it correctly or not. हाँ, correct. हाँ, sinistral. Hope it's clear now, huh? Okay, good. Okay, so I think my flow got a little bit disturbed, but no issues. We talked about this, and from there we got somewhere else, but it's good that the doubts got clear. Yeah. So yeah, what I was going to discuss after this, I think that would help you to answer the questions of your assignment as well, the other questions. It's the geomorphic features that we get in this strike slip fault system. So just remember these things because they could be in your exam or in anywhere if you give exam. So first thing, we understood that whenever there is a strike fault, there would be an offset of the drainage. So suppose, and which is very obvious or evident, that if this stream is flowing like this and if this fault got moved here, so definitely this path will got changed when we move to the other side of the block. So this is the one thing, that whenever there is a strike slip fault, there would be an offset, and this offset could be a stream or could be a drainage. Okay. Another feature that we get during this strike slip fault is the linear valley, because due to this, so whatever in this you were talking about that there is a movement. So this is not the dip movement, it's a valley that it has created. And why it is not a dip movement, this I think we'll talk in the later of this section. But so far there is no frictional kind of feature. It's a very smooth plane if you see. So there is no any frictional kind of movement, or there is no any directional pattern that has created, that should be created if there would be a dip slip fault. Okay, but there is no these kind of features, so that's why we are saying that it's a valley. So it's a linear valley, linear because it is creating along this linear strike line. Sorry? Yeah. So this is the second feature. So first is there would be definitely a offset. Second, that there would be a formation of a linear valley. And the third and the most important that you have heard most of the time is the sag pond. So how the sag pond formed, that during this relative movement there would be some area where the depression would be very high. So suppose here, like from this rest of the area, this particular area has the highest depression, and now this depression, what will happen, now there is a stream is flowing, so water is there, or there could be a rain after this movement, so this depressed area will get filled by water, and this is how the seg point will form along this strike line or along this strike slip fault. So these are the main geomorphic features that always remember are formed by this strike slip fault. And the major example of this strike slip fault is the San Andreas fault. Okay, so now I think this concept we have already discussed. Moving to this, I think this question will give me the satisfaction that whether you have understood everything so far so good or not. Now you have to answer this question, okay? So the question states that a rock body is, okay, I think, okay, just try to answer, then we'll discuss because there's a concept here, we'll discuss. A rock body is deforming in extensional energy environment. How the block will move? Okay, so here what is the key point in this question is the extensional energy environment. Now tell me what is the, just tell me what is this extensional energy environment, and if you don't know then no issues, we'll discuss it anyway. No, extension, just focus on this word extension. What is this extension, like in normal language? No, it's external. Extension means extension means you are pulling something, like you are extending something. Yeah, see, whenever you get confused, just go to the basics and just try to understand the basic things first, otherwise you will get confused. So if we talk extension means we are extending something, we are stretching something, right? And if we talk about compression, like we are compressing something, means yeah, we are here, the movement would be like this, we are compressing and pushing, and here the pushing could be two-way, so we'll use the extension and the compression. Okay, so to again understand this, because these concepts are important to identify that whether the hanging wall will move up or down. So let's understand this extension or compression environment once again, because through this simple figure. Okay. So first is the tension or the extension, because the implication of this tension is extension, right? It is extending, or the length is increasing. And how you can increase a length? Suppose you have a rubber and you want to increase its length, so definitely you will stretch it, or stretching or tension. So in a simple language, just remember that tension is equivalent to stretching. Okay, so now it's a stretching. Now here we simply focus on the fall part, so I am skipping other part. Okay, so we don't get confused. So during this stretching we are getting normal fault. Now the question comes, why? That's the important thing to understand. Though you can remember this thing, but I think we can understand it with some logic. So if I'll apply all the concepts that I have taught you so far, is that this is my fault plane, correct? And if I want to distinguish between the hanging and the foot wall, what I'll do? I'll draw the perpendicular. So this so I'll draw my perpendicular. So this left hand side would be my hanging. Why? Because it's in the upward direction. And the below downward side would be my foot pole. I just write the foot. Now this hanging wall, now if I see the movement, it's going downward, correct? with respect to this football block because it is in the up position, but my hanging wall is going down. Why it is going down? Due to the effect of the gravity, because it is extending, and due to the weight of this hanging wall it is going down because it is the upper direction of the fault. See, this thing you have understood now, that how I marked the hanging and the foot wall, and how I have understood that hanging wall is going downward and this foot wall is in the up position. Yeah. Now what I was saying, that why this hanging wall is going down, it's because due to the gravity. Here the gravity force is acting. Okay, clear? Yes. So this is how. Yeah, but if we talk about in terms of gradient, so whoever it's on the what I say, it's on the sliding side. See, yeah, it's on the sliding side, so that thing will first go down, right? So that case is applicable for the hanging wall. Now moving to the second scenario, that it could be, it's the compression. And here in compression, what we'll feel, we'll see the shortening, and which is very obvious, like if you compress anything, definitely it will get shortened. Now what happens, so this kind of scenario or this kind of energy or the stress condition, okay, yeah, could lead to reverse fault. And now you can understand that why hanging wall is going upward now. Yeah. No, what did you say? Right hand side is the hanging wall, right? Because again, if I'll draw a perpendicular, this side is the up direction, so it's hanging, and it's in the below. Okay. Now moving to the third scenario that we have is shear, which is a very simple one, because here we are using different kind of terminology, so you shouldn't get confused here, because there's no concept of hanging and the foot wall. So here's the concept of dextral, sinistrial, I think I wrote the wrong, but okay, I'm very bad at remembering. Okay, yeah, so if you are standing at this side of block, so it is going in the left, yeah, it would be a sinistrial. Correct. Good, Akshay, you are learning so fast. Okay, so let's move to the other part, the last question for this session. Okay, yeah, sorry. So here what kind of energy it is? Extensional. Extensional means it could lead to normal fault, NF. So in normal fault, what happens, that here gravity acts, and what gravity does, it pulls the hanging wall down. I think everything is clear, huh? Hanging wall will move down, so this would be the answer. Or if they could frame a question like this, that there is a shear energy is acting, so the answer would be this, that block will remain stationary, because here no upward downward movement is happening now, so they are stationary. Yes. Yeah, correct. Okay, so yeah, we got the answer for this question. Now moving to this question. So what it says, that dash are the features on the fault plane indicating the direction of the movement of fault. So this is the thing I was talking about when we were discussing about the strike slip fault, that there you were not able to identify any slip features, or there's a movement has happened, like downward movement. So here we are talking about that features only. So we have to identify that among all these options, that slick insides, fractures, lineations and joints, what are the features that form due to the movement or the dip slip movement along the fault. So now to answer that question, like first understand a few terms, though we have understood I think, but let's revise it. So joints you already know. So this is the field photo. So there you can see that here we have even horizontal joints as well, and inclined and vertical. So this is a joint, and it could formed as a result of the contraction which can happen due to the cooling or the consolidation of the rock. And these joints, so always remember, these joints can also be happen due to the compression or the tension setting. So these are the joints. Now moving to the lineation. So have you, yeah, due to the tension and compression, yeah, there could be okay. So if I'll go to my first slide, there what we have seen, like if we go to the basic definition of the fracture, what you are saying that when the rock breaks, yeah, resulting as a fracture. But if we see the definition of the joint, what it says that if there is no movement, it's same like the fracture, because in fracture also there is no movement is happening. But if there are many other fracture with same orientation, then the fracture are called as joints. I hope you got your answer now. So they are fractures, yeah, they are joints are fractures, but when they happen in a set, or when there's a many fractures, we called it as a joint or joint set also. Yes. So this particular rock has multiple fractures that you can see like this, horizontal, vertical, inclined, everywhere. So that's why we are calling it joints. Yeah, if there will be a single vertical, it would be a fracture. But when there are multiple of vertical fractures, then they form a joints. Okay, so these are the definition of joints. Let's understand now lineation. So have you know about lineation? Okay. So let's understand it by definition first. So what it says that they are used to describe any linear structures that occur repetitively in a sample of rock, okay, which tells us the direction in which rocks stretched or moved during the deformation. Because these linear features generally happens due to the stretching of the rock, that you can see over here, like there are lots of, not the continuous, but this black pattern is more of like in linear fashion. And when we cut that sample, what we find, we'll find the dots of this black features that on the upper side is continuing, but when we'll take the cross section, we'll find this dots kind of feature. And the analogy of similar to what? ओशन में वेव्स, मतलब जो सॉरी बीच पे वेव्स आती हैं. Mm-hmm. But here it's in the rock. Okay, you are saying, okay, when there is a rock on the beach side, so okay. Mm-hmm. Okay, I got your point, but I don't think, because here they are generally formed due to the deformation, and that the pattern that is created by the wave, I don't think that would be considered as a deformation, because there's no stretching or the compression phenomena is happening. So yeah, so that's the major, like, black dots increase color means. Yeah. Yeah, simply deformation of that particular rock, that could be due to the stretching. Yeah. And if anyone show you the the rock sample, so this is how it should, like, if the lineation has happened to this rock, this particular. Now the third is the slicken side, which I think you probably knowing about it. So it's a smoothly polished surface that caused or formed by frictional movement between rocks along the two sides of the fault. Now this definition says a lot, and if we'll take the field photo and you identify that this kind of feature on one rock, because there might be chance that when you will go to the field you didn't find the football or the hanging wall, but because due to the erosion that remnant has completely gone, and there are few remnants that difficult to decode. So then in that scenario you can look or you can look for these kind of features. Yeah, so if you identify these, so these are the calcite deposits which was part of the other side of the rock, and that has are present in this. So this is the calcite slicken sites, and there could be a quartz also. Yeah, the direction, if we, so it is going like this, so then yeah, you can, yeah, fault has moved. Yeah. And there's another category where you don't find the other material like calcite or the quartz, so there could be simply lineations kind of features, like linear features, which will help you to identify the movement. And I think that movement has happened in the up direction. Up direction or down, I think it, yeah, right, yeah, in this. But here, like in the first image, it's easy to say, because we can see the movement of this calcite. These are depositing like this. But here, yeah, but here, yeah, it is difficult to say whether. Okay, sorry, okay, yeah. So I was saying that in this first image, it's pretty much clear. It's not visible. What? Okay, how it got disconnected? Okay, wait. I think it would be visible now. Yeah, sorry. So yeah, from this second image, it bit hard to tell, but from this first image we could infer due to the like pattern of this calcite deposits. Correct. You can see that it is depositing downward if you try to see the pattern. So the answer of this question, that what are the features? So definitely fractures are not, lineations are not, joints are not, because they are formed after the deformation. So the slickened side would be the right answer, that they are formed due to whenever there is a relative moment along the fault plane. So I think this is it, Akshay, from my end. So yeah, that's it. So I hope you have understood today's session. Yeah. Okay, okay, okay. Glad to know that. Okay. Okay, Akshay, then I'll first let me stop presenting. Okay, then I'll, yeah, okay, thank you, and hope to, yeah.